Theorem from this section is the equidistant chords theorem. In the same circle or in congruent circles, two chords are congruent if and only if, so there's that biconditional statement again, they are equidistant from the center. And remember, distance is considered the perpendicular between the two things. So segment AB is congruent to segment CD if and only if EF equals EG, which they do here according to this picture. All right, so in this particular example, QR equals ST, which equals 16. So this is 16 and this is 16. CU equals 2x, CV equals 5x minus 9. Find the radius of circle C. Okay, so the first step is to find CU. And we know that CU equals CV because of this theorem over here. These two are congruent, and this is an if and only if, so it's biconditional. I can go backwards. Since these two segments are congruent, these two line segments must have equal measure. So I'm going to set 2x equal to 5x minus 9. Subtract 5x from both sides. Divide both sides by -3. So x equals 3. Now I'm going to plug that back in, and CU equals 2x, so it will equal 2 times 3. So that means 2CU is 6 units long. Okay, now find QU. Well, because our diameters, or because our diameter is perpendicular, so see this, WX is our diameter, and it's perpendicular, I can say that it bisects that segment. So that means that QU equals UR, and we were already told that it was 16, right? So QU will be half of 16, or that the total was 16, so QU is 8. And then finally, find CQ. CQ is going to take a little bit more work. Again, I know that CU is 6 and QU is 8. CQ is this distance right here. So if I rewrite this, perhaps you'll see it better. I have our old friend, the right triangle. So we said this side was 6, this side was 8, so I'm going to use the Pythagorean theorem. CQ squared will be 8 squared plus 6 squared, 64 plus 36. So CQ will be the square root of 100. Technically it's plus or minus, but we can't use a negative distance, so we're just going to use 10. By the way, you might also have noticed that this is a 3, 4, 5 triangle. 8 divided by 2 is 4, 6 divided by 2 is 3, and 10 divided by 2 is 5. 3, 4, and 5. This is what we call a Pythagorean triple.